Just start with the first AI session that we like Pratik and I made for the new DeepSeek hype and AI trends going on in the market. So just a quick this image is also generated by an AI. Like I have automated like made the logo live. So this is one thing. So our team is Pratik, Akshay, and Alphonse for right now. In future, we might add some other team members. So first of all, we go to the who made the DeepSeek possible, what was his idea behind it, and how the open source LLMs are going forward in the direction. So the Liang Winfeng, he's the CEO of DeepSeek. Like everyone knows about the Sam Altman. So I think everyone should know about the Liang Winfeng. He's the genius. He worked in the Wall Street. He made some algorithms that predict the market trends, and they are very scary. Like he works in the company named Hyunfang Quantitative, which works in the quanta investments. Like they are like far different from the current investment, like stocks and all. So they works in the crypto market itself. So I made one theory, like researching all through 36 and the stock market fall in the US, and everyone is making some theories. Like I have made one theory, like he works for the Henfang Quantitative. Yesterday, I was going through the Binance news reports where Trump thanks to the Henfang Quantitative for 5 trillion US dollar flooded back into the cryptocurrency circles. But the fun fact is like the main Len Winfing works for that company. So you get my point, right? So in the meanwhile, like he has done the thing like when he kept the money towards the US itself and worked for like the main thing, like stock goes down and crypto goes up thing. So this was one theory. Like another breakdown is like I saw the yesterday's stock market. Like everyone is talking like stocks are going down, but the meanwhile, for the first half of the day, Nvidia and other stocks goes down. But in the second half, people realize that Apple's chips are more effective than Nvidia, and Apple stocks are in the positive right now because the M2 Ultra chip, which was released back then, is more useful for running the R1 or other LLMs locally more effectively than H100 because the H100 GPU are more capable for multitasking and all kind of stuffs. But the DeepSeek's V3 R1 model have 671 total parameters, but only 37 billion parameters are active token generation. So that we can say that we need less memory as compared to the H100 and all GPUs. I have made this relevant because uh, in terms of the speed, in terms of the cost, we need to figure out which infrastructure we need to use. Yes. So Vic has tried that the R1 on his Mac. So yeah, why M2 is useful very like it has the unified memory chipset. Like CPU and GPU share the single memory pool, which separates the memory data and copying kind of stuff. Like for H100, we need to work CPU and GPU separately. So that's the main thing. From now on, Pratik will tell you about the theory, like what actually the DeepSeek is.
Yeah. Hello. Hello. Am I audible? Yeah. So actually, I was facing some issues of Google Meet. So I will give you a brief walkthrough of how DeepSeek model has been trained and how which different techniques of training the models are available there. And first of all, there these are some prerequisites for the session, which is supervised fine tuning and reinforcement learning. So LLMs are basically trained using different techniques. So supervised fine tuning and reinforcement learning are the two mainstream training processes we can say. So in supervised fine tuning, uh, we can see there are multiple steps. So first is of selection of a model. So a base model is selected, which is already trained on a large number of data. And this model is then trained on our personal model, which is a task specific data set, which trains this model. After training this model, we can this data set explains which type of task it's aligned to it. So I will give you a brief walkthrough through a code of a Google Colab. Okay, okay, just a sec. So I'm actually using Access laptop, so can't show you the code right now. But just a sec, I will see. I can show if I can show. Yes. So sorry, there was some issue in code loading and Google Meet. I will show you the code right now. So I will start from beginning. So basically, supervised fine tuning is a training method. So it trains on a base model. We provide it with a task specific curated data set, and we choose a loss function which decides the how close the results of model is with the original model. So in this, I'll show you the reference code. So yeah, so me and Akshay previously did a small course on supervised fine tuning. So in this, I have first set up my Hugging Face environment, and then I have called a small model, which is Hugging Face TV small LM2 135 million parameters model. So this is very a small model. It doesn't work perfectly, but so when I ask it about write a haiku about programming, this is how its result look like, which is very bad actually. So after that, I have loaded a fine tuning dataset. So yes, it's redirecting. So yeah, so I use this dataset for fine tuning the model. So it contents of the content and user response. So on this dataset, the model trains and improves its reasoning ability and response capability. So further, I have set up few parameters in SFT trainer, which is maximum steps, then training batch size, learning rate, logging steps, and other parameters. So based on this configuration, we train our model on a newly curated dataset. So as you can see, after once the training process is done, I have run it for 1,000 epochs, and after the model training, we can see how the model performance has been improved. Like you can see over here, like this was the earlier response. Like when I asked her write a haiku about programming, it gave me the same query in response. But when I asked it again after pre-training, so it gave me like this, like, hello, how are you? I'm going to write about haiku about programming, what's programming, etc. So this is how you can improve uh, your model performance. So in this supervised fine tuning, there's also a process called as freezing the model layers. So in freezing the model layers, what you do is, so our model is made up of different types of layer. So the deeper layer consists of mostly of the general purpose of the model, and the upper layers consist of mostly can be tweaked with the help of this. So there's also an option in supervised fine tuning where you can freeze the denser model layers and you can fine tune the upper layers of model. So moving on into the code, into the slides. So next is our reinforcement learning. So reinforcement learning is basically a reward-based learning. There are different learning methods like supervised learning and unsupervised learning. So in supervised learning, we use labeled dataset. In unsupervised, we use unlabeled dataset, and we train our model. But in reinforcement learning, we let our agent to explore its environment and learn on its own. In this, we have implemented a reward-based system. So if agent takes a proper action, it will be rewarded. So it's a mathematical function. It gives him a positive scores uh, if it performs action properly. If not, it will give its penalty into a negative number. Uh, in the diagram, you can see a block called policy. So policy is basically acts as a agent's brain. So if the agent, so policy decides if this action is correct or not, and the agent keeps on updating this policy as it's keep learning and exploring the environment. So I will give you a reference code. So yeah, so this is a reinforcement learning basic implementation. So I have set up a agent and I have given it an obstacle. So let's suppose this is a grid and our agent is at its base, that is 0, 0, and it has to reach its final destination is coordinate 3, 3. But I have blocked the path of 1, 1 and 2, 2. I have created an obstacle. So agent can't grow from in a diagonal way. So it has to find a new way to reach to 3, 3. So so this is the environment which our agent is going to work. And I have set up action for this agent, which is up, down, right, left, and right. So based on this, the model updates its policy and improves and understand which way uh, agent will reach faster to its destination. So I have set up a Q learning agent. So this is a value-based agent which uh, understand different values and takes the best value out of it. So here's a Q table which you can see. So we have set up the action as up, down, left, and right. So you can see when agent is going to start its journey, the most optimal path for it should be going to the right. So as you can see, it has given 69 to up, to value to down, and 58 to left, but it has given 90 to right. So as 90 is greatest and it's the reward system, so it considers right is the best option for agent to move, and similarly agent trace down the path to its destination. So this is how reinforcement learning works. So yeah, so this was some prerequisites related to this session. Now we will dive into DeepSeek V3 base model. So DeepSeek V3 base. So as I have told in supervised fine tuning, every model that is been trained, so it needs a base model to be trained on. So DeepSeek R1 and R10 uses DeepSeek V3 base as its base model. So there are some key architectural function that DeepSeek V3 does. So first is mixture of experts. Second is multi-head latent attention. Third is multi-token prediction. Fourth is load balancing. And fifth is FP8 mixed precision. So these are key architecture features of DeepSeek V3 base. So what exactly is mixture of experts? So DeepSeek V3 base is made up of 671 billion parameters, but it only uh, activates 37 billion parameters out of it. So it reduces computational cost by a lot, and only selected relevant experts parameter uses are being used during the process. In multi-head latent attention, whenever user inputs a query, whenever it gets some input, it understand which words are better and which words carries more weight than the rest of the words. If the other method is single attention, latent attention, in which the model gives equal priority to every single word, but in multi-head latent attention, it differs priority based on the word and its sentence formation. The next is auxiliary loss freeloading balancing. So, um, as I have told you that V3 based model is made up of 671 billion parameters and 37 billion parameters are used as per task. But this auxiliary load balancing takes care that the 37 billion parameters which are chosen are not being used, or like used for multiple times. It chooses parameters accordingly. It diverges the load between the different parameters. So it helps to reduce computational cost and improve the model performance and efficiency. Traditional LLM, we have seen that there are single token prediction. That means based on the rest of the sentence, it predicts what word would fit better in the sentence. But in multi-token prediction, it predicts multiple words or the next sentence. So it improves the speed of model in general. Then another is FP8 mixed precision training. In this, it uses a 8-bit floating point format for certain computation. So it reduces computational cost and efficiency and increases efficiency of model. So these are 5 key architecture feature of DeepSeek V3 base model. And based on this model only, we have trained and like improved a model for achieving R10 and R1 models of DeepSeek. So further on, let's go into DeepSeek R10 model. So DeepSeek R10 model is basically a model which has been trained using pure reinforcement learning. There has been not a single step of supervised fine tuning in in DeepSeek R10. So DeepSeek were the first one who proved that reinforcement learning can also improve model performance and can provide a better and strong reasoning solely through reinforcement learning. So that's the differentiator of DeepSeek if we compare it with OpenAI and other LLMs. Because other LLMs you traditionally use supervised fine tuning, so it takes a base model and then fine tunes it and makes a better model on the previous one. But DeepSeek used reinforcement learning to improve DeepSeek V3 base model and uh, moved forward and improved its reasoning to generate DeepSeek R10 model. So there are 3 main pillars of DeepSeek R10 architecture. First is reinforcement learning algorithm, obviously, because as we have been told that DeepSeek uses pure reinforcement learning in R10 architecture, and it uses group relative policy optimization. I will talk about this in further slide because it increases efficiency of model and reduces computational cost by a lot. Then another is reward modeling. So uh, I will talk about this in further slide again. So what is policy optimization? As I have told you, that policy acts as the brain of agent. So whenever agent thinks like has to take an action, whether it has to go left, right, up, down. So policy optimization helps it that which is the best case scenario. And then the policy keeps on getting updated as the agent learns and explores through his environment. So to improve this policy optimization, there are 2 main methods, which is policy-based method and value-based method. The previous one, the code flow I have shown you about reinforcement learning, use value-based method, which is about Q learning. And in DeepSeek has used policy-based method, which is PPO, which is proximity policy optimization, and GRPO, which is group relative policy optimization. So these are 2 techniques used for policy optimization. So yeah, so this is a structure of PPO and GRPO. So the main the main reason that DeepSeek chose GRPO over PPO is that PPO uses a critic model. So critic model helps in optimizing policy and tell policy like which is the best scenario or which is better. But the problem with critic model is that its size is bigger, and also it takes a huge computational cost on PPO. So in GRPO, we have removed the critic one. So it basically compares groups of action results. So if a group of actions has been given some reward, then takes the same action uh, in the further step and compares it with the previous steps and decides whether the model has performed better or it has gone adverse. So based on this, the GRPO decides and optimizes the policy of agent. So see, this is a working of GRPO. So GRPO first samples multiple output. So it samples multiple output, then rank responses with sample set, and then updates the model by reinforcing better ranked responses. So this is how GRPO basically works. Moving forward, the reward modeling in DeepSeek R10. So as we know, reward works as a training signals, acts as a training signal for agent to learn. So DeepSeek has mainly used two types of rewards, which is accuracy rewards and format rewards. In accuracy rewards, it has checked is the model's capability of solving maths problem or solving coding tasks and etc. So it also in accuracy records it also checks. So if you give a maths problem to DeepSeek, it checks that if the model is giving the final output in a box or not. So if it gives the final output in box, it provides it with accuracy rewards. And the another one is format reward. So in during the chain of thought process of DeepSeek, so DeepSeek goes through a multiple chain of thought process, and for during thinking of this process, it has to follow a format accordingly. So these are the tags. So these are the think tags it use. So these are the think tag it use. So it thinks in this tag and answers in specific tasks. So this so yeah, here it is. So enclose within think and think tags and clearly provide answers within answer tags. So this is the way how DeepSeek R1 promotes the for accuracy rewards and format rewards. There is also one more reward called as neural rewards. They actually tried using neural rewards in their DeepSeek R10 modeling, but it was causing a lot of biases, and it was quite easy to hack into the reward procedure. Basically, the model was finding a different loophole in the reward system, and hence the neural reward was not included in the final DeepSeek R10 model. Moving forward, this is a training template. So the DeepSeek R10's thought process has been provided with a clear training template. So it has to think in a similar format to maintain the consistency of answers and the consistency of its thinking process it's been going through. So as explained earlier, it thinks in a proper enclosed tags of think tags and answers in proper answer tags. So self-evaluation process of DeepSeek R10. So reinforcement learning provides a edge over supervised learning, supervised fine-tuning, because in this we do not have to explicitly tell model that it has to understand or learn in a similar function or in a specific way. The model understands and grows on its own. So as they have seen, when they have run multiple iteration, the DeepSeek R10's performance kept on increasing on its own. So like for example, let's consider its base response. So if you say what is 3 plus 3 to the DeepSeek R10 base model, then it will say, yeah, 3 plus 3 is 6. That's its thinking process. But as it moves forward, so it tries to cross-check whether the answer is correct. So it will go like, yeah, 3 plus 3 is equal to 6. But let's check what is 6 minus 3. Yeah, it's giving 3 again. So it cross-checks and evaluates itself and hence grows its thinking capability and reasoning capability accordingly. So there's so while reading DeepSeek R10 research paper, I came across a aha moment. So as us human have an aha moment, like we are like if you are giving a like we have been given a code problem, then we think on it, and then suddenly we have an aha moment, like yeah, like this is the solution. So DeepSeek also provides a quite long thinking process, thinking time than as compared to other model, as it thinks and reasons itself and evaluates its previous response and comes across the aha moment. And once it comes across aha moment, it flags it. And yeah, so that's the thinking process of DeepSeek R10. But there are few drawbacks of DeepSeek R10, that there was poor readability. So the output given by DeepSeek R10 was not up to date, and it was breaking sentences. Another one was language mixing. Like it was mixing languages like Chinese and English while providing the output. So these were few drawbacks of DeepSeek R10. So, based on this, they understood that reinforcement learning can work, and they incorporated reinforcement learning and supervised fine tuning to make their final product, which is DeepSeek R1. So, in DeepSeek R1, they trained the model in 4 different phases. So, in first phase, they used a supervised fine tuning. Then the second phase was again reinforcement learning, and they repeated the same again. So, reinforcement learning, supervised fine tuning, then reinforcement learning, and finally again supervised reinforcement learning in the end. So this is how they trained the DeepSeek R1 model. So there were 4 main phases. One is cold start fine tuning. Second is reasoning oriented reinforcement learning. Third is rejection sampling. And fourth is again reinforcement learning for all scenarios. So cold start. So basically, whenever you try to train a model, there always a cold start. Like a model is unstable and produces very poor results in the beginning. In the beginning stages of its training process. To overcome this cold start, DeepSeek did was it trained it on a supervised fine tuning data. So it collected different prompts and different data from DeepSeek V3 and DeepSeek R10 previous models, and they chose the best responses and curated a proper cold start data for fine tuning V3 base model. So they also use the prompting technique called as few shot prompt technique, and created multiple responses. And while these responses were good, there were few of them which were rejected, which will come in the next stages. So based on this, they overcome the cold start that every model faces. So they first use supervised fine tuning in DeepSeek. After that, after using supervised fine tuning, they trained the model like they trained the DeepSeek 0 version. So they trained it again on a reinforcement learning. So it went on through a huge iteration of reinforcement learning training, and same reward based system was there. Like agent used to learn from it, and this second phase was mainly focused to improve the coding, mathematical and logical reasoning of the model. So this was about second stage of reinforcement learning in DeepSeek model. So yeah, so this is the rejection sampling. So multiple prompts and multiple samples were created for training the DeepSeek version, but only the best output or best responses were selected. So DeepSeek not only wanted to create a reasoning model, so it also wanted that DeepSeek could do a general AI purpose, which is like answering factual questions or a role playing. Like if like we give a prompt, like you are a software engineer and give me a code for this. So DeepSeek also wanted that. So it created a data set based of reasoning data and non-reasoning data. So it trained the model on 600K samples of reasoning data and 200K samples of non-reasoning data. And so finally, 800 total samples were trained, and this improved the model reasoning capability by a lot. And the last one was again a reinforcement learning. So the last stage of model training was about improving its capability across all the aspects. So it to enhance helpfulness, harmlessness, and reasoning capabilities. Reinforcement learning was incorporated in this, and yeah. So these were the main 4 stages how DeepSeek model was trained. Now, moving forward to how distillation, like, so what distillation is. So distillation is basically you take a larger model and train a smaller model on it, and the smaller model kind of works like the larger model. So they have created different distill models which are available on Hugging Face, by the way, which are of 1.5 billion parameters and 7 billion parameters up to 70 billion parameters. So they train different Twain and Llama models on DeepSeek V3 model, and generated their distilled model. So I will give you a brief walkthrough to how distillation works. So yeah, so this is one of a teacher model I have created. So this is basically uses a hyperbolic space which is more complex, and needs more. It's more suited for doing complex problems. This is the first model, and the second model is quite is of lesser specs, so it doesn't use hyperbolic space and all. And then I have set their reward functions, then their training functions, like how models should be trained. And I will show you, I have created one distillation function where the knowledge of a teacher model has been transferred to the student model. So this is a function, and then I have done a main execution. So I have trained it for 10 epochs, as you can see over here. Yeah. So I actually have created one more notebook. Mm, yeah. So yeah, for testing the dataset, I have created one more notebook. So in this week, as we can see, so for the same query and for the same dataset, the teacher model, uh, teacher responses is this, and it's been rewarded from 0.9961. And similarly, the distilled student response is also rewarded 0.95, which is quite comparable. This like if we consider their specs, the student models shouldn't be able to perform so well, but after distillation, it is almost as comparable as teacher model. So this was the process of distillation. And yes, so now Akshay will take on this.
Now the theory part has done. Like I will walk through you to the actual things like how to use for the hackathon perspective and to get start in the field of AI. So as you know, the experiment that's done for the Payless shoe stores, like it was the low price shoe store, and they rebranded it as playlists. Uh, they have the same products, but they sell that one shoe for the greater amount in the playlists. Uh, it is same for the all the LLM companies. Like they are doing the same thing, but they are just branding and giving the things expensive, more expensive. Like in terms of open source, DeepSeek is like a Payless to store, and the OpenAI is like a PlayCC. So now next we goes to the Hugging Face. Like everyone knows the Hugging Face, but some of them who doesn't know the Hugging Face, I just quick walk through in the Hugging Face. So Hugging Face is the platform where you can find all the AI or AI related or machine learning related models. Every company like who works in the field of open source put their original models which a user can experience and use them in their open source projects on the Hugging Face. Like Hugging Face has the three sections. One is models, datasets, faces, and people post. People use their docs. We can read all the trending topics here. We can get all the news of trending topics. Let's just search for the DeepSeek. So here you can see DeepSeek AI has their own page, which is verified by the company. They have their own collections of models, like Pratik has already mentioned, like DeepSeek V3, DeepSeek VL2, DeepSeek V2. All the open source models are present here. Let's go to the DeepSeek R1 model. Here we can find all the DeepSeek R1 model from the Distill Llama 70B Distill Queen models, then original DeepSeek R1 models. Like we can use this model, but we need GPU and we have to pay to the Hugging Face for the GPUs. Uh, I have created one a short project. Let me just show you. So this project I have created using the Distill Queen 1.5B model. So I just quick walk through like how we can create a normal project and how we can made a pipeline and call the Distill Queen model, which is present on the Hugging Face. So we just need to create, click on the your profile picture. Like everyone has to create one account on the DeepSeek as we have on the Hugging Face, as we have the QD42 organization present on the Hugging Face, where me and Pratik are going to upload some of the normal projects that we create, tools for the company. So now create one new space from here, then add us any name like DeepSeek or anything. Select the SDK. For AI development, some of the free libraries are present. One is Gradio, one is the Streamlit, which provides us the UI for the machine learning models to run, or the LLMs. Then we have to create a create space. It is just like an GitHub, but we can directly deploy our models. So let's just check this model where I have asked the query, who are you? I have added some max length of token and something like that, because 1.5 billion model is very low powered model and it takes too much time to give the answer. Like, who are you? It doesn't think as this was the simple question, and it gives me output. I am a Dixit R1 artificial intelligence assistant. So let me just walk through towards the code. In the files, we can create multiple files. It's just the structure like GitHub, where we have to create the files. The app.py is the main file that runs. So this is the simple code. Like we have to install the transformers library. Then we have to import the pipeline, and from the pipeline, we just need to call that DeepSeek AI the still queen 1.5 billion parameters model. So like DeepSeek R1, when we go to here, we just need to copy this path. After copying this path, we just need to replace that part. So it is that simple. Like we can create any kind of GUI, any kind of agentic machines through in the Hugging Face, and we can try it out. We don't need to locally install or anything like that. It's just online. And also we need to put some requirements, which doesn't need to go into that deep much, but I just wanted to show you like this is how we can create the AI application. It's just for an hackathon perspective. So anyone has any question like what else we can do on the Hugging Face? So we can get the actual data set like in further step where I'm going to tell you like how to fine tune. So these are all data set which are open source, and we can use this data set to fine tune our model. Like in traditional machine learning, we use data sets to train the machine learning models. In the same way, we can also train the LLM, like it's called the fine tuning for our personal data sets. So now let's just go to the DeepSeek Genus Pro 7B model, which is the multi-model, which has the capability of visual. So just show you the Genus 7 Pro B model. So I think this can be used in many use cases for the companies. So let's just demonstrate how it works. So the visual or the multi-model has two parameters. The first is like understanding what is there in the image, and then after understanding, we just pass that understanding towards the LLM. And one more thing is there, like what should be generated in the stages. So understanding and generation, the DeepSeek has combined both in the stage 2, and then they pass that information to the stage 3, which is the fine tuning, where the task is there. Like for this image, the input is like an image where it encodes the information about the dog, and the user pass the prompt like what is the color of the dog. So these two information are going to the DeepSeek Genus Pro model, and it will give the result in terms of the dog is brown. So I will not go into the architecture deeply, but this is how things works. And in the generation task flow, like how images are going to generate. So DeepSeek's Genus Pro 7B model has already pre-trained some of the images, but it maps through the user's prompt, like create the image of the brown dog. So it tokenizes that text and pass it to the autorecursive transformer model, which generate the image by taking the older inputs from the model itself. So this is how DeepSeek works. So this was the image given to the DeepSeek Genus Pro model and explain this meme. So it will first understand the image and then gives us the response. And another example is like generating the image. So this was the prompt and it generated this kind of images. So this can be the this is the future of the image generation and all, and DeepSeek is doing well in that. Like we can see the results. Currently, it is on the top right now. but some multi-models are coming on the lineup. So now next, let's see what is the onslaught. So fine tuning locally, it is not very cheaper as compared to training the machine learning model on the basic GPU. So fine tuning needs a large amount of VRAM. So currently we can't afford the large amount of VRAM. So there is one startup called as Onslaught AI. They provides the open source tool that can accelerate the fine tuning models. Like it reduces the memory usage by 80%. Like in the image, you can see the comparison. So it will give 1.95x fine tuning speed for the basic fine tuning task as compared to the PyTorch, which is widely used for the larger RAM perspective. So I'll show you how you can use this fine tuning technique in the hackathon. So this is the GitHub page of Onslaught, where you can find all the free notebooks that are available on the fine tuning perspective. Like we have, if we need to fine tune the Llama 3.2 billion 3.2, which is the 3 billion parameter. So we just need to click and open it in the Google Colab notebook. This notebook has all the codes, like how to fine tune from basic to end. Even the evaluation part is also they have done the evaluation part in that also. So we just need to select the which model we want to fine tune, and don't need to change this parameter, as these parameters are set to use the GPU in less, and we need to change the data set. Like currently it is using Melbourne data set. So this all things we need to change and nothing else for the faster and better results and better GPU usage. It works on the free version of T4 GPU, which is given by the Google Colab itself, which is free. So this is what the Onslaught is. Now let's fine tune the real R1 model. So I have created my own, which is going to be published in this Onslaught. Currently it is not there, but I will give you the link of this notebook that I have created for the fine tuning Onslaught. So I have loaded DeepSeek R1 Distill Llama 8 billion Onslaught BNB 4-bit model. So after loading that model, we just need to give some permissions. So we need the Hugging Face token, as we need to import that model into the Google Colab notebook. After that, we need to load the dataset, which is the Wcagli Apache GPT-4. So I will show you this kind of data set that we are using to train. This data set doesn't have any other capabilities like thinking and all, but it's just the instructional database. Like identify the find odd man out, then it will identify the odd man out from that. This is all it does. Nothing like coding and all kind of stuff, this data set. So we are fine tuning the R1 model for this data set. So let's just see, give 3 tips for saving. This is the data set actually. After that, we need to make that data set which is compatible for that model. Like every LLM has their own capability of data set capability. Like this data set has the content and role. Actually, this data set has the instructions and output as the data set parameters, but we need to convert that into the content and role kind of parameters. After customizing the database, we just need to use the Onslaught to process this data set, and the main part comes like how to train that models. So these are the parameters. So currently I am using LoRa technique, which is the fine-tuning technique which was introduced in 2021. So this is the LoRa adaptation technique. After that, many more fine-tuning techniques had come, but this fine-tuning techniques needs the GPU. So currently, I'm using the LoRa technique. In later slides, I will show you how these things works. After training the model, we need to store that model. Like the Onslaught itself provides storing the model into the Hugging Face. It provides the pipeline. which directly stores the model into Hugging Face, and that model we can use. So currently for this notebook, I was just trying to install the Olama and use that model locally itself. Like it will store the model in this file section and load that model and use it. I'm not running as my GPU has exhausted. So another thing that Colab has the limit for the GPU usage. I don't know exact the limit, but we can run this fine-tuning notebook once for a week for one account. After fine-tuning and after loading that Olama model, we can just use that model like normal Olama. We need to. I have model. I have named that model DeepSeek fine-tune model. We just need to load in Olama chat, and then we have to pass the prompt like this. It will give you output like this. So this is all like how to add a chart into a document, so it will give the proper response like this. So fine tuning means that you are quantizing that model for your specific data set, which can be like more useful than using the original model. That's all the fine tuning is. So another thing in the fine tuning, like the traditional fine tuning, we can do like this stuff. Like we use all the codes and everything to just fine tune all the models. But OpenAI has given their own APIs to fine tune the models. So I will provide that link. You guys can try it out or check like OpenAI GPT model, how to fine tune the OpenAI GPT model, that as they currently not available on the Hugging Face or open source. Now comes the
I think maybe
part,
maybe a
like,
basic.
yeah.
Sorry, should I ask the question later or
Yes.
like a basic question? Like, what's the difference between RAG and fine tune? Like, RAG will
Okay.
also bring a layer of your own data on the LLM.
Yes.
And in what cases do you fine tune? In what cases do you use RAG?
Okay. So from my understanding, the current, if you have the good data set which can be used for the fine tuning, like if you have the good database, you can use the fine tuning. If we don't have the database, good database, like we can't do like this kind of data. If we doesn't have this kind of data set, like we don't have enough data set actually to train the model, we can't use the fine tuning. So that's the case. Like if we have a little bit data set, we can use the RAG itself.
Okay. So is there a comprehensive like when to fine tune, when to use RAG? Like if there is data, but what kind of data and like when to fine tune, when to use RAG, and what are the benefits?
So RAG has its own benefit. Like RAG is the different thing than fine tuning. We can give the live data to the RAG, but in fine tuning, we are just using the old previous data that we have already. Based on that, we fine tune the model and quantize that model for ourselves. Like it was like our own child. We are giving him instructions, and the RAG is kind of thing where people give the external like schooling education to the child, and child works on that. Like homegrown is fine tuning, and
So I understand that between the techniques, but use cases, and what use cases do you want to use fine tuning? In what use cases would you use RAG? Given that there is enough data.
If there is enough data, so that's one thing I can't currently thinking of. Like if we have enough data, we can use the fine tuning, and if we want, if the data is changing regularly, then we can use the RAG. I just wanted to show you one quick example. So this one is the notebook LLM powered by the Google. So here we can add all this kind of source. Like it's more like we can add up to 50 sources, where we can add website, we can add YouTube videos, as many as we want. We can add Google Docs, we can add Google Slides, we can even add the Google. We can even add the GitHub link of our codes also, and we can chat with that. So this kind of system is called RAG, and here this kind of system we need RAG actually. If user wants to work the LLM on their own data. I think I answered it. Right now, I can't give the proper example, but RAG and this are two different things, and use case is different. So this, can I continue?
Yeah, go ahead, please.
Okay. So if I can here, I would like to show you this tool. Like everyone can use this tool. This is the open source tool. Open source, not open source, but this is the free tool where user can put all the sources, like up to 50 sources, which has a very large amount of context window, and user can chat. There is an audio overview which is running currently, but after this done, we can directly chat with our all the stuff, from even from YouTube video to all kind of stuffs.
Actually, sorry to interrupt. I think the wrong screen is visible.
Okay, I thought that this is it visible now? Sorry, I just, just yeah. So this was the tool given by the Google Notebook itself, where we can add all the sources from Google Drive, like Google Docs, slides, websites. As many websites we can add, up to 50 currently. There is a limit also. And then we can add the YouTube videos also. And we can also paste the text like a normal RAG. We can put all MP3, markdowns, PDFs, text, everything. All can be seen here. And we just need to click like which dataset we need to use, and we can select all the stuff, and then we can chat with it, and we can also talk with it. So it's just, so give me a code of RAG. I have put my one GitHub repo there, and it will show me where I can get all the codes, like in this kind of thing. And for AI sessions, I put reinforcement learning for all the scenarios. Then it has given me this source kind of thing where I can see all the PDF slides which has this stuff. So this is more like new stuff going on, and people can use, like everyone can use for study purposes, better RAG system. So now let's go to the interesting part, like what is important in the main established company like OpenAI and open source models. So I have jailbreak the DeepSeek current scenario. Like if we ask about the China's sensitive topics to the DeepSeek, it will not reply, but we can bypass that. So I have created one hexadecimal code, like you can see here. I have pasted this code, which has tell me about the about that incident in 20 sentences, and put the dot for each character, and this will create that hexadecimal code, which can't be understand by the DeepSeek model, as it as it provides the guardrails after the results. At currently for Alpha's project, like for Ilao project, we use the guardrails for query itself, but DeepSeek doesn't do that. DeepSeek do guardrails after the querying. So the same question, if I ask this without using this kind of stuff, so it is giving me the output like this. And in the next chat, if you ask like this, so it will give this response for the same query. And let's see. So this kind of stuff. So currently I found two techniques which bypass that guardrails of DeepSeek. One is using the hexadecimal code, and another one is changing the language. Like I put the Hindi text there, and it will directly bypass all the systems. Like it will give you the output which it's not supposed to give output. And this works for the entire chat, like chat session for this window. I can ask any question. So now it is jailbreaked, and I can ask any question which can't be answered by normal DeepSeek. So these things we need to keep in mind when we are using the open source LLMs. Like we need to put our guardrails. And another scenario, like Tipen mentioned earlier, like fine-tuned models doesn't give this kind of responses as they are specially fine-tuned for the specific data set itself. So this one more advantage for fine-tuning RAG systems. So it's not like DeepSeek is open source. That's why I able to jailbreak it. In 2023, when GPT 3.5 also released, I have tried to jailbreak it. If the screen is readable, you can read like how GPT works when it got jailbreak. So it will give all the unnecessary and content violation information also legally. Like we need to keep eye on that, like how we are going to put our guardrails to our models that we are using. So as everyone stated so far, I just wanted to give one bonus tool. Like I use it for my projects and college stuff. Like everyone can use this tool. This is the extension for the Visual Studio. And I will change. So this kind of extension. Okay. So we can use this extension. So which in our project there are too many files. Whenever we have a meeting, we just go to the Figma and draw the stuff and explain it to everyone. We just need to put .tldr extension after file name, and we can use this tool for generating the architecture diagrams and all. And we can also share this. We can also export all the things. We can insert from the Figma. We can insert the Google Map, YouTube, all kind of pipelines. We can use the GitHub list, everything. So anyone can use this. We can also upload the media, like if you want to add something, images or like that. So this is the cool extension that everyone can use. So now let's go towards the next techniques. As I mentioned earlier, what is the AI revolution from last 12 years? So first of all, it starts with the what-to-wake models, AlexNet models in back 2020, 2012 and 13. Like people use these models currently also for pattern matching and like document matching thing. Now the GANs comes, then resonates, OpenAI founded in 2015, then Wave RNN, like CNN, RNN, LSTMs kind of things came. But main evolution comes in 2017 as the transformers came, like BERTs and GPT-1. Like BERT transformers are widely used back then. And then their next versions like Roberta, Albert, Distilberts, and GPT-2 has come. Then in 2020, in COVID, they found the vision transformers are also quite capable of generating images and understanding of images. Then the DALI came, GitHub Copilot came, and the fine-tuning techniques came. Like model size is getting increasing day by day. So fine-tuning and quantization of model, it is very much needed as we want to run it locally or on the different systems. So from 2001, people go deep into the research of the fine-tuning. Then the image generation part came in 2022, and in 2023, the Llama, Mistral, which are open source models, they came, and GPT-4 also came, like that. So these are some of the fine-tuning techniques like QLoRa, LoRa FA. Like to explain, the QLoRa is like you can guess it is a quantization LoRa technique. One is a factorization LoRa techniques. Then adaptive LoRa technique, Delta LoRa technique, LoRa Plus, which is enhanced LoRa. And currently there is one another technique called as DORA, which is the distributed LoRa. So we can use these techniques to fine-tune the models more effectively, and which has the better accuracy, but we need the GPUs. So in the last, I just wanted to show you the two big giant companies in the China which are currently leading. Alibaba also came yesterday, but I didn't add it here because as it's not launched perfectly. So I would like to show you the two tools. One is DeepSeek, like everyone using DeepSeek. It has the R1 capability and it has the search capability. Another tool like DeepSeek has too many traffic and it is not currently working properly as it always shows server down. So you can use this Kimi Moonshoot, Kimi model, which is same like a DeepSeek, but it is a multi-model which has better capabilities than the current DeepSeek models. I would like to see. If I found something, I will. Okay. So here you can see the key results of Kimi are better than the current present models. So let's see the how DeepSeek. Is there any comparison with DeepSeek? Or you can just try it out. I will post that link of Kimi also in the chat box. That's all for now. So it has better chat history as compared to other tools. You can see everything, and it has the better capability of research itself. One more thing I would like to tell you, if you are searching for a specific task on the Google, it will show a very miscellaneous website. So try to use this online mode from like web search mode from each LLMs, OpenAI, DeepSeek, and Kimi, or you can even use it in cloud. So it will give you the better results. So that's all I want to say. Thank you, guys.
Thank you, Akshay and Pratik. It was a nice, insightful session. Anyone, any thoughts you want to share?
Yes.
Yeah, go ahead. Yes.
I would just like to know that, let's say, if someone is participating in a hackathon, let's say it has identified the problem statement. Now, are there any best way or best practices to follow to select the model and the data set for the problem statement to resolve?
So Alphonse can give that.
Oh, okay. Yeah, I was saying, the best way to would be to just to pick up the best free thing that you have out there, like initially, and then slowly tune down to smaller models. There is no directory out there where you can just put your use case and get the best model for your use case. You start out with a very generalized model. A generalized model is something like GPT-4, or you don't even have to go for the reasoning models yet for most use cases, unless it's something really complicated. But yeah, general models, and once you're getting good results out of it, you can slowly go for specialized models or smaller models. Like it's mostly a trial and error. Okay. But yeah, we all start with general models. It could be
But is
general
there any way to identify that let's say
with general
if
model.
I go ahead with the GPT-4, okay,
Mhm.
the problem statement I gave that I am trying to fine tuning it, but not getting the desired output, then are there any means way to identify that now this is the capacity of this model and now we need to move to the other model?
Mm, Are you also confident that your prompt, or let's say whatever, however you fed the model is perfect, or it's the best that you could do?
Yes. So
Okay.
I'm just trying to understand.
Yeah, even I'm like trying to question everything. Yeah, I don't have a specific answer for this.
I
For
think
me,
there
that's
needs to
just
be some sort of. See, I think everyone is. Okay, before that, I think, sorry to hijack your question, Vivek. Maybe the answer will come from that. Can you briefly talk about what's the hackathon format and like just talk about the hackathon? Is it a team-based thing? How is it gonna work? I saw a long notice, but was like a little bit not clear in terms of the readability, so kind of
oh
skipped it.
Yeah, it was it was only supposed to be readable on a larger screen, or let's say horizontal on a laptop screen. Anyway, um, hackathon, anyone can participate. Anyhow, the idea is that you pick up a use case of your own. You pick up quite literally anything. No one's gonna be judging in the judging in what you are going to do. Then you build out something out of it, like a really small POC. Use publicly available, any kind of libraries or no code tools as well. We have planned a session next week introducing how to use Lambflow for more comprehensive workflows, like ingesting weird kind of data formats and turning into insights, or even taking actions using Lineflow or similar no code tools. So we are hoping you guys could just create good workflows, or turn your use case or POCs into, sorry, not POCs, your ideas into small POCs and workflows that could be judged on. We would have a show and tell somewhere around Feb end. Sorry, second last week of Feb or last week of Feb, depending on how the engagement is around this. And yeah, we'll so depending on how useful it was and so on, we have few people that will judge or more like decide which use cases could be taken forward and which use cases can be turned into a full-fledged project, or it can be
So
including.
hackathon is an individual exercise, first of all, right?
Again, it's your choice. I'll put out that message in a more clear way. Again, like I remove the brackets and stuff. Yeah, it's not just an individual. Some people might want to do it individually. Some people can do it in teams. If two of your friends are having the same thought or same idea that you want to do, just team up and you can do it. There's no registration as such. All that matters is what you bring forward by the end of the hackathon. But we would be having like many sessions, like maybe twice or thrice in a week, about using different tools, about building small workflows in them to help you get acquainted um, with these tools so that you can bring your ideas to life, or you can build at least the smallest version of your idea on some no-code platform to begin with. Yes, Akshay.
Like I would like to add one thing in the hackathon perspective. Like you can check out the Everyday AI and AI channels where we post all the new technology and all new agents and all kind of stuff which has very low code, and they are easy to implement. Like, so one of the tool I would like to show you. It's take 1 minute only. So it's just 40 lines of code where there are too much uh, comments out there, but it's just like 20 lines of code where you can use the new technology of browser use. It's just one use case. I was trying to find, like I find almost 8 to 9 use cases of this, but anyone can build a project around it. So this is, I think this can be a next big thing in current era of AI. So it will directly show you the prompt after this has done. So the prompt is like, go to this website and search for the work and choose the distracted boyfriend meme template and put this text over there. So this will work like this. So this is the single line prompt where it scraps all the web pages. It finds out this meme. It will put all the stuff. So it will find the check like things where we usually put our text. Then it will put the text. So this is how it will work. And it also clicks on generate. Like I'm not doing anything. It will directly generate and saves it. So this is how you can use these new agentic tools which are directly working on the browser itself. There is another tool of computer use. So this tool is browser use. So there are numerous possibilities by using the computer use. So it will also generate one GIF that what that agent has done. So it will also put the captions over there. So you can find your own use case and build something. Thank you.
Yes, Rahul, I saw your hand being up. Do you still have anything to say?
Yeah, I was just thinking that if we can have a procedure or a workflow to make sure, means what will be the correct workflow if we are trying to create a model using a specific use case, that will be great.
Sure, I'll put it out more clearly by
Yeah,
end of the
just a
report.
workflow
Yeah,
that what is the best practice if we are creating a model for a particular use case, then what should
sure.
be the base?
Sure. Yeah, I'll put a comprehensive guide by probably Monday.
And I think,
Since
did we
Friday
do
after.
any kind of a session on how to use Google Colabs notebook?
Yes.
Or if there's a
Mm,
is there a YouTube video which you can link? Because I think uh, sometimes it's probably like good to explain different sections in the notebook as to what they do. We don't have to create any tutorial, but if there is already that is existing, can link.
Yeah, the area interns will share a few resources. So, yep, can do. Yeah, makes sense. Uh, anyone, anything? Anything else? Feel free to add all your concerns under the hackathon thread. I will take them up and reply in the service sometime. Yeah, Akshay, pretty good.
Yeah, so to answer Vidit's question, that we can actually use a few short prompting, like we can give the our model and our a prompt like which tells like this should be the output, this should be the structure of output, and with few examples it learns on its own. So you can use that in your workflow.
Okay. I will try out something, and if I need, then I'll reach out to you.
Yeah, sure.
Hello. I wanted to add one more thing. Like probably today or tomorrow, there will be one blog around how to use the LLMs locally on your phone. So that can be another topic that you guys can try out. Like this can be a big things in mobile application development in next scenarios. Like we don't need to use the API keys for that stuff. So we can directly run that model in our mobile phone itself, like low quantized models in our mobile.
Actually, me and Akshay have done many POCs around the different topics. So, if Alphonse, we could share those same GitHub links and the demo links to the to on a general group, it will be more helpful for them to go through that workflow.
Yeah, yeah. Also the thing that we mentioned, Pratik, Akshay, the demos that we were going to host on Spaces, if
Yeah.
you remember. Yeah.
Yes, yes.
Yes.
We will do
I
it.
think and it'll be great to have like the QED GitHub and Hugging Face being populated while we are doing all this exercise, so that we also get like we are trying to get a lot of AI business, not just in marketing, but business outcomes and other stuff. And our general profiles should be, like have those examples and other stuff. Uh, so yeah, it'll be good that maybe hackathons could be one uh, organization within QED. I don't know how do we want to do it, but it'll be good if the output of it, if it's specially curated output, is on the Hugging Face and the GitHub of QED.
Yeah, we do have organization in the Hugging already set up like long ago. And the interns are currently working on converting their all the little POCs into spaces, Hugging Face spaces. We are like 10 instances that can be. Yeah, they're working towards it. Also, the hackathon stuff and all whatever comes out of it. Out of it. It's like,
Cool. All right. Thanks, everyone. I'll drop off now. Thank you.
thank you.
Thank you.
Thank you.